In this lesson we will see events and event handlers in action. This is a long lesson, so let's dive into it immediately. You should have a folder called Delphi Schools Video Projects on your desktop. You also created a few graphical user interfaces in lesson 13, and you saved the projects in the Delphi Schools Video Projects folder on your desktop. For the purpose of this lesson, we will continue with the program called Age Calculations. So go ahead and load the Age Calculations application into Delphi's IDE. In a previous lesson, we coded the Calculate button's OnClick event. Double-click the Calculate button. This takes you to the event handler called btn Calculate Click. Remember now, when you double-click on a component in design time, Delphi creates an event handler and link it to the component's default event. We already typed instructions between the begin and end statements in this event handler, and we already tested that code. When we tested the code, we confirmed that the event handler executes when the Calculate button is clicked. That should tell us that Delphi automatically linked this event handler to the OnClick event of btn Calculate. Let's go and make sure about that. Display the form and select the Calculate button. Notice that btn Calculate's name is displayed in the Object Inspector. Click the Events tab of the Object Inspector. Here you can see a list of the events that the button can respond to. To view the names of the events and event handlers properly, drag the right edge of the Object Inspector to widen the window. There you can see that this button has an OnClick event. Next to the name of every event you can also see blank cells. Only the cell next to the OnClick event is not blank. It shows the word btn Calculate Click. This is also the name that was assigned to the event handler in the code editor. So, this indicates to us that Delphi linked the OnClick event of btn Calculate to the event handler with the name btn Calculate Click. Let's now explore the events of a bit button. Display the form again and select the Reset Bit button. This bit button's events are listed in the Events tab now. Here you can see that we do not have event handlers linked to any of the events listed in the Events tab. Let's find out what is a bit button's default event. Double-click the Reset Bit button. Delphi creates the skeleton for the bit button's default event. Here we can see that this event handler is called BMB Reset Click. And now we can also see in the Events tab that Delphi linked the event handler to the bit button's OnClick event. That tells us that the bit button's OnClick event is the default event. Let's write code between the begin and end statements to reset everything back to their original states. Let's start by removing the captions for the two panels. Next, reset the two spin edits to their original values of 1 and then set the focus back to the first spin edit. This code will only execute when your user clicks on the reset button. Let's run the application to test our code. Change Mary's age to 17. Change John's age to 16. Click the Calculate button. Let's quickly explore the changes that took place. Firstly, the two spin edits changed. Secondly, the captions of the two panels display messages now. Thirdly, the focus is now on the Calculate button, because that is the last component that we clicked on. If you look closer, you will see a dotted rectangle inside the button. That's how we know that it has focus. Now, click the Reset Bit button. Let's look what happened. The spin edits display once again, the panel's captions was removed, and the focus is back on the first spin edit. All this happened because you coded the click event handler linked to the OnClick event of the bit button. Close the form to switch back to design time. Let's add a label to the bottom of the form. Drag the bottom of the form to adjust the height slightly. Select the blue and gray panels and bring them down a little bit, like this. Select the label you just added. This label's name is still label 1. Click the Properties tab of the Object Inspector. Change label 1's name to LBL Instructions. Click the form surface to select it. Click the Events tab of the Object Inspector. Here you can now see a long list of properties that FRMH calculations can respond to. Double-click on any open space on the form surface. Delphi creates an event handler called FormCreate. The FormCreate is therefore the event handler linked to the form's default event, which is the OnCreate event. This event will be triggered when the form is created in memory. In other words, when the program starts and in the process of creating and displaying the form, this event is invoked. Let's write code to change the caption of the label we added a few moments ago. Add the following code between the begin and end statements. This code changes the label's caption to the phrase, right-click a panel to see more info. We can set this caption in the Object Inspector, of course, but I want to illustrate to you how and when a form responds to the OnCreate event. Run the application, and here you see the result. The label's caption displays the phrase as we coded it. This label's caption is changed when the form is loaded in memory, but before it displays on the screen. The phrase in this label's caption is too long, so we must use the scroll bars or change the width of the form to see the whole caption. A label's caption only displays on a single line by default. Let's go and change that so that this phrase is displayed on multiple lines. Close the form to switch back to design time. Select the label. Click the Properties tab in the Object Inspector. Now scroll to the bottom of the Object Inspector. Change the word wrap property to true. This property enables the label to display its caption on more than one line. Let's go and test it. Run the application. As you can see now, the label displays the phrase on more than one line. Close the form to switch back to design time. The label's caption tells the user to right-click on a panel to view more information. So, let's provide more information when our users right-click on one of the panels. Let's start with the blue panel. The purpose of this panel is to display the result of Mary's age plus John's age. When our users right-click on a panel, we must show a message in a pop-up window that explains the purpose of this panel. Select the blue panel. Click the Events tab in the Object Inspector. A list of all the events that the panel can respond to is displayed in the Events tab. Let's first find out which event is the default event for this panel. Double-click the panel. Delphi creates an event handler called P&L Result Click. In the Object Inspector, we can also see that this event is now linked to the OnClick event of the panel. The OnClick event is therefore the panel's default event. However, we are not interested in the OnClick event. We want this panel to respond when the user right-clicks the panel, not when he or she clicks the panel. So, we are not going to type any code between the begin and end statements in this event handler. Remember now, if we don't write code for any event, nothing happens when that event is invoked. Let's see what Delphi does when we run the application without writing any code. Run the application. You can now go ahead and click on the blue panel and see that nothing happens. That is because we didn't write any code for the OnClick event of the panel. Close the form to switch back to design time. If you explore the code editor now, you will see that Delphi even removed the event handler because you didn't write any code for it. If you also look at the Events tab, you can see that the link to the event handler is also removed from the OnClick event. If we need the panel to respond when a user right-clicks the panel, we must use the panel's OnContext pop-up event. Click in the cell next to the OnContext pop-up event in the Object Inspector. At the moment, this event is not linked to any event handlers. The cell next to the OnContext pop-up event is blank. To create and link an event handler to an additional event, you must double-click on the blank cell next to the event's name. Let's do that. Delphi creates an event handler called P&L Result Context Pop-up. We can also now see in the Object Inspector that this event handler is now linked to the OnContext pop-up event of the panel. Now let's write code between the begin and end statements in this event handler. Type the following code exactly as I am typing it. Let's quickly analyze this code. Remember, it's a good practice to comment your code to explain what the purpose of your code is. Here, we call one of Delphi's built-in procedures called showMessage. The showMessage procedure expects a string argument between the brackets. So we pass the phrase that reads, "This panel displays the sum of two ages." When the user right-clicks on the panel, this code will execute and Delphi will show the message in a pop-up window. Let's test it. Run your application. Now right-click on the blue panel. A little window pops up in the middle of the screen and shows you the message that you provided in your code. This message window is also called a dialog window. Before you can do anything else, you must first close the dialog window. You can do that by simply clicking on the OK button. Now right-click the gray panel. We didn't write code for this panel's OnContext pop-up event, so nothing happens. Let's go and write code to also show a pop-up message for this panel when the user right-clicks it. Close the form to return to design time. Select the gray panel. Events for P&L average age is now listed in the Object Inspector. Double-click the blank cell next to the OnContext pop-up event to create and link a new event handler. Delphi creates an event handler and links it to the panel's OnContext pop-up event. Type this code between the begin and the end statements. This code is the same as before except that the message reads, "This panel displays the average of two ages." Run your application. Now right-click on the gray panel. Another dialog window pops up with a new message. It now displays, "This panel displays the average of two ages." Click the OK button to remove the dialog window and close the form to return to design time. Here on the top of the form we have two spin edits. I want the spin edit's color to change to yellow when it receives focus, and I want it to change back to white when the focus moves away from the spin edit. But let's first find out which event is the default event of the spin edit. Double click on the first spin edit. Delphi creates an event handler called SED Mary's Age Change. This event handler is linked to the onChange event of the spin edit. The onChange event of the spin edit is triggered when the user changed the current value in the spin edit to something else. We are not really interested in this event. We want to write code that must execute when the spin edit receives focus. The event that will be triggered when a spin edit receives focus is called OnEnter. Double-click the cell next to the OnEnter event in the Events tab. Delphi creates an event handler called SED Mary's Age Enter. You can still see the name of the event handler linked to the onChange event in the Object Inspector. But don't worry, because we didn't write any code in that event handler. Delphi will remove it next time you run your application. Now let's write code between the begin and end statements in this event handler. Type the code that I'm typing. This code will change the spin edit called SED Mary's Age to yellow as soon as the spin edit receives focus. Let's test it. Run the application. The spin edit on the top immediately changed to yellow. That is because SED Mary's Age is the first component that receives focus when this form is displayed. If you look closer, you will see that the number in the spin edit is highlighted in blue. That indicates to us that the focus is on this spin edit. You also know that the spin edit has focus if the insertion point displays inside that spin edit. Click inside the second spin edit. The second spin edit has focus now because the insertion point is inside it. The focus was therefore moved away from Mary's age. Click on the Calculate button. Now the focus moved away from John's age and is now on the button. Let's go and write code to change the spin edit that displays Mary's age back to white when it loses focus. Close the form. When a component loses focus, its OnExit event is triggered. So let's create and link an event handler for the OnExit event of SED Mary's age. Make sure SED Mary's age is the selected component. Double-click in the blank cell next to the OnExit event in the Events tab. Delphi creates an event handler called SED Mary's age exit and links it to the OnExit event of the spin edit. Type the code that I'm typing between the begin and end statements of this event handler. This code changes the color of SED Mary's age back to white when the spin edit loses focus. As you can see in the Object Inspector, SED Mary's age can respond to more than one event. In this case, it responds to two different eventualities that occur at two different times. One when the component receives focus, and one when the component loses focus. Let's test it. Run the application. Mary's age gets focus first, therefore it is yellow. Click inside the second spin edit. The first spin edit changed back to white when the focus moved away from it. Click inside the first spin edit again. It changes to yellow again because it received focus again. You can also move focus from one component to another by pressing your Tab key. Whenever the tab lands on Mary's age again, it will change to yellow. And whenever the tab moves away from it, it will change back to white. Here you can see how I do it. So, you can click on a component to give it focus, or you can press the Tab key until it receives focus. Okay, now I have a challenge for you. I want you to pause the video at this point and see if you can do the same with the spin edit that shows John's age. John's age must also change to yellow when it receives focus, and it must change back to white when it loses focus, just like Mary's age. Try it first without cheating, so don't rewind. Only if you really tried it and you're still stuck somewhere, you can cheat and look how I did it for Mary's age. After you're done, you can resume the video. Please note that this is not the end of this video. Come back and start the video again after you completed the challenge. Okay, you may pause now, and good luck. Okay, I hope you got it right. This is the best way to learn. You must get your hands dirty in the code. Let's continue with this lesson. The next thing we must do is to make the buttons pop when the user moves the mouse pointer over a button. To make a button pop, you place emphasis on the button. You want it to stand out. That can be done by changing the color of the button or by changing how the caption appears when the user's mouse pointer moves over the button. Listen carefully now. When you move your mouse over a component, you are not giving it focus. You are only giving it focus if you click on it or if you use the Tab key to select it. So let's make our buttons pop. Let's start with the Calculate button. Select it. We already have an event handler linked to the OnClick event of the Calculate button. Remember, this is the default event of the button. We now also need to create an event handler for the code that must execute when a user moves the mouse pointer over the button without clicking on it. Select the Reset Bit button. We also have an event handler linked to the OnClick event of the Reset Bit button. And this is also the default event for a bit button. But we also now need to create an event handler for the code that must execute when a user moves his mouse pointer over this bit button without clicking on it. Now select the Close Bit button. We do not have an event handler linked to the OnClick event of the close bit button. Remember, if a bit button's kind property is set to bkClose, it has its own built-in code to close the form when it is clicked. So we do not need an event handler for the OnClick event at this time. However, we need to also create an event handler for the code that must execute when a user moves the mouse pointer over this button, without clicking on it. Our aim is to place emphasis on a button when the user's mouse pointer moves over that button. Let's start with the Calculate button. Select it again. Make sure that btn Calculate is the selected component in the Object Inspector. Double-click on the cell next to the OnMouseMove event. Delphi creates an event handler called btn Calculate Mouse Move and links it to the OnMouseMove event of the button. This event will be triggered when the mouse pointer moves over this button. Now, let's write code to make this button pop when the mouse pointer touches it or moves over it. Type the code that I'm typing between the begin and the end statements. The font size of the button is 8 by default. When the mouse pointer moves over this button, its font size must change to a bigger size. In this case, it must change from 8 to 12. Let's test it. Run your application. Move the mouse pointer slowly to the Calculate button. As soon as it touches the button, the caption changes to a bigger font. You don't have to click or select the button. And that is how you make a component pop. When you move the mouse pointer away from the Calculate button, the font size doesn't change back to a smaller size. But we will write code for that later. Let's write code to also make the two bit buttons pop. Close the form. Select the Reset Bit button. Double-click in the cell next to the OnMouseMove event. And type the code between the begin and end statements to change the font size of BMB Reset to 12. Let's do the same for the Close Bit button. Select the Close Bit button. Double-click in the cell next to the OnMouseMove event. And type the code between the begin and end statements to change the font of BMB Close also to 12. Okay, now let's test our code again. Run the application. Move your mouse pointer to the Calculate button. When your mouse pointer touches it, it pops. Move the mouse pointer downwards to the Reset Bit button and it also pops. Move down to the Close Bit button and that one also stands out now. The next step is to change the buttons back to a smaller font when the mouse pointer doesn't touch a button anymore. We do not have an event that is triggered when the mouse pointer leaves a component, but we can work around that. The three buttons are contained in a panel, and when your mouse pointer moves away from a button, it must touch the surface of that panel. It doesn't matter where you move to when you move away from a button. Your mouse pointer will always touch the panel that contains the buttons. To change a button's font size to a smaller font when you move away from it, you need to write code to make it happen when the mouse touches the surface of the panel that contains the button. Let's go and do that. Close your form. Click on any blank space of the panel surface to select it. Make sure P&L Actions is selected in the Object Inspector. Double-click in the cell next to the OnMouseMove event of this panel. Type the code that I'm typing between the begin and the end statements. This code changes the font sizes of all the buttons back to a smaller font size. In this case, we change it back to 8. This happens when the mouse pointer touches the surface of the panel that contains the buttons. In other words, when the mouse pointer is not touching any buttons. Now let's test that. Run the application. Move your mouse pointer to the Calculate button to make it pop. Move away from the Calculate button towards the Reset Bit button. While you are doing that, notice how the Calculate button's font size changes back to a smaller font when the mouse pointer moves over the panel surface. When the mouse pointer touches the Reset Bit button, it also pops. And when you move away from it towards the Close Bit button, it changes back to a smaller font. You can also test this behavior on the Close Bit button. Try it by moving the mouse pointer at different speeds. It doesn't matter how fast or slow you are moving the mouse pointer. If a button is touched, it pops. But if the panel surface is touched, the buttons are normal again. Now I want you to keep your eyes on the yellow highlighted spot that indicates where my mouse pointer is on the screen. I'm going to move it to the right of the form so that it doesn't touch anything on the form. Now look at the components on the form. I am using the Tab key to shift focus from one component to another. When the edit that displays Mary's age has focus, its color is yellow. And when the focus moves away from it, its color changes back to white. When the tab moves focus to the button, however, nothing happens. The buttons do not pop when they receive focus. That is because the mouse pointer is still on the right hand side of the form. In other words, it is not touching anything on the form. Please don't get confused with the OnMouseMove and the OnEnter events. The OnEnter event is triggered when you select a component by clicking on it or by using a tab key. The OnMouseMove event is only triggered when the mouse pointer moves over the component. Okay, I can't leave you with a half-completed application. Earlier I gave you a challenge. I asked you to go and code the OnEnter and OnExit events of the spin edit that shows John's age. When John's age receives focus, its color must change to yellow, and when it loses focus, its color must change back to white. To complete this lesson, I'm also going to demonstrate that. So, see if you got it right. I will close the form to switch back to design time. I select the spin edit that shows John's age. Then I double click on the cell next to the OnEnter event of the spin edit. Between the begin and end statements, I add code to change the color of SED John's age to yellow when this spin edit receives the focus. Then I double click on the cell next to the OnExit event of the spin edit. Between the begin and the end statements, I add code to change the color of SED John's age to white when the spin edit loses focus. Okay, now I want to test the code. I run the application. The first spin edit has focus, therefore its color is yellow. When I move the focus away from the first spin edit, it changes to white. And because the second spin edit gets the focus next, it changes to yellow. If I press the tab key again, the focus moves to the Calculate button. Because the second spin edit loses focus, its color also changes back to white. Our application can do many things now. And that is all possible because our components respond to various events. You can now play around in the GUI and make sure that you get all the responses that you have written code for. If you want, you can apply this newfound knowledge to more components and maybe to some of the other applications you created in lesson 13. Remember, practice makes perfect. In the next lesson, I will demonstrate to you how to identify and fix errors. I will also demonstrate how to fix other problems that you may encounter in the IDE. So, I'll talk to you again in lesson 23.